In professional audio, a mixing console, or audio mixer, also called a mixing desk, audio production console, soundboard or simply mixer is an electronic device for combining, routing, and changing the level, timbre and/or dynamics of audio signals. A mixer can mix the analog or digital signals, depending on the type of mixer. The modified signals are summed to produce the combined output signals. Mixing consoles are used in many applications, including recording studios, public address systems, sound reinforcement systems, broadcasting, television, and film post-production. An example of a simple application would be to enable the signals that originated from two separate microphones to be heard through one set of speakers simultaneously. When used for live performances, the signal produced by the mixer will usually be sent directly to an amplifier, unless the particular mixer is powered, or it is being connected to powered speakers. Among the highest quality bootleg recordings of live performances are the so-called soundboard recordings that are sourced from this mixer output to the speakers. Structure. A typical analog mixing board has three sections: channel inputs, master controls, audio level metering. The channel input strips are usually a bank of identical monaural or stereo input channels. The master control section has subgroup faders, master auxiliary mixing bus level controls and auxiliary return level controls. In addition, it may have solo monitoring controls, a stage talkback microphone control, muting controls and an output matrix mixer. On smaller mixers, the inputs are on the left of the mixing board and the master controls are on the right. In larger mixers, the master controls are in the center with inputs on both sides. The audio level meters may be above the input and master sections, or they may be integrated into the input and master sections themselves. Channel input strip. The input strip is usually separated into these sections: input jacks, microphone preamplifiers, equalization, dynamics processing, routing including direct outs, OSENs, panning control and subgroup assignments, input faders. On many consoles, these sections are color-coded for quick identification by the operator. Each signal that is input into the mixer has its own channel. Depending on the specific mixer, each channel is stereo or monaural. On most mixers, each channel has an XLR input, and many have RCA or quarter-inch TRS phone connector line inputs. Basic input controls. Below each input, there are usually several rotary controls. The first is typically a trim or gain control. The inputs buffer the signal from the external device, and this controls the amount of amplification or attenuation needed to bring the signal to a nominal level for processing. This stage is where most noise of interference is picked up, due to the high gains involved. Balanced inputs and connectors, such as XLR or phone connectors, reduce interference problems. There may be insert points after the buffer gain stage, which send to and return from external processors, which should only affect the signal of that particular channel. Effects that operate on multiple channels are connected to the auxiliary sends. Auxiliary send routing. The auxiliary send routes a split of the incoming signal to an auxiliary bus, which can then be used with external devices. Auxiliary sends can either be pre-fader or post-fader, in that the level of a pre-fade send is set by the auxiliary send control, whereas post-fade sends depend on the position of the channel fader as well. Auxiliary sends can be used to send the signal to an external processor such as a reverb, which can then be routed back through another channel or designated auxiliary returns on the mixer. These will normally be post-fader. Pre-fade auxiliary sends can be used to provide a monitor mix to musicians on stage. This mix is thus independent of the main mix. Channel equalization. Further channel controls affect the equalization of the signal by separately attenuating or boosting a range of frequencies, for example, bass, mid-range, and treble. Many mixing consoles have a parametric equalizer on each channel. Some mixers have a general equalization control at the output. Q system. The Q system allows the operator to listen to one or more selected signals without affecting the console's audio outputs. The signal from the Q system is fed to the console's headphone amp and may also be available as a line-level output that is intended to drive a monitor speaker system. The terms PFL and AFL are used to characterize the point in the signal flow from which the cue signal is derived. Input channels are usually configured as PFL so the operator can audition the channel without sending it to any mix. Consoles with a cue feature will have a dedicated button that is typically labeled cue on each channel. Solo in place is a related feature found on more advanced consoles. It typically is controlled by the cue button, but unlike cue, SIP is destructive of the output mix. Its purpose is to mute everything except the channel or channels that are being soloed. SIP is useful for setup and troubleshooting in that it allows the operator to quickly mute everything but the signal being worked on. For obvious reasons, SIP is a function that would be dangerous to a mix engineer's career if engaged during performance. For this reason, most consoles require very deliberate actions by the operator to engage SIP mode. Subgroup and mix routing. Each channel on a mixer has a sliding volume control that allows adjustment of the level of the channel. The signals are summed to create the main mix, or combined on a bus as a submix, a group of channels that are then added to get the final mix. There may also be insert points for a certain bus, or even the entire mix. Vca groups, found on higher-end consoles, voltage-controlled amplifier groups function somewhat like subgroups but differ in important ways. Vca groups allow the level of multiple input channels to be controlled by a single fader. Unlike subgroups, no submix is created. The audio signals from the assigned channels continue to be routed independently of Vca assignments. Since no submix is created, it is not possible to insert processing such as compressors into a Vca-Dca group. In addition, on most Vca-Dca equipped consoles any post-fader auxiliary send levels will be affected by the Vca master. Usually this is desirable as post-fader auxiliary sends are commonly used for effects such as reverb, and sends to these effects should track changes in the channel signal level. Master output controls. Subgroup and main output fader controls are often found together on the right-hand side of the mixer or, on larger consoles, in a center section flanked by banks of input channels. Matrix routing is often contained in this master section, as are headphone and local loudspeaker monitoring controls. Talkback controls allow conversation with the artist through their monitors, headphones or in-ear monitor. A test tone generator might be located in the master output section. Returns such as those signals returning from external processors are often in the master section. Metering. Finally, there are usually one or more VU or peak meters to indicate the levels for each channel, for the master outputs and to indicate whether the console levels are clipping the signal. Most mixers have at least one additional output, besides the main mix. These are either individual bus outputs, or auxiliary outputs, used, for instance, to output a different mix to on-stage monitors. As audio is heard in a logarithmic fashion, mixing console controls and displays are almost always in decibels, a logarithmic measurement system. Since it is a relative measurement, and not a unit itself, the meters must be referenced to a nominal level. The professional nominal level is considered to be plus 4 dBu. The consumer-grade level is a 10 dBV. Hardware routing and patching. For convenience, some mixing consoles include inserts or a patch bay or patch panel. Patch bays are mainly used for recording mixers. Other features, most, but not all, audio mixers can add external effects, use monaural signals to produce stereo sound through pan and balance controls, provide phantom power required by some microphones. Some mixers can create an audible tone via an oscillator. Add effects internally. Read and write console automation, be interfaced with computers or other recording equipment, control or be controlled by a digital audio workstation via MIDI or proprietary commands, be powered by batteries. Digital versus analog. Digital mixing console sales have increased dramatically since their introduction in the 1990s. Yamaha sold more than 1,000 PM5D mixers by July 2005, and other manufacturers are seeing increasing sales of their digital products. Digital mixers are more versatile than analog ones and offer many new features, such as reconfigure signal routing at the touch of a button. In addition, Digital consoles often include processing capabilities such as compression, gating, reverb, automatic feedback suppression and delay. Some products are expandable via third-party software features that add further reverb, compression, delay and tone shaping tools. Several digital mixers include spectrograph and real-time analyzer functions. A few incorporate loudspeaker management tools such as crossover filtering and limiting. Digital signal processing can perform automatic mixing for some simple applications, such as courtrooms, conferences and panel discussions. Consoles with motorized faders can read and write console automation. Propagation delay. Digital mixers have an unavoidable amount of latency or propagation delay, ranging from 1.5 ms to as much as 10 ms, depending on the model of digital mixer and what functions are engaged. This small amount of delay is not a problem for loudspeakers aimed at the audience or even monitor wedges aimed at the artist, but can be disorienting and unpleasant for IEMs where the artist hears their voice acoustically in their head and electronically amplified in their ears but delayed by a couple of milliseconds. Every analog to digital conversion and digital to analog conversion within a digital mixer entails propagation delay. Audio inserts to favorite external analog processors make for almost double the usual delay. Further delay can be traced to format conversions such as from ADAT to AES3 and from normal digital signal processing steps. Within a digital mixer there can be differing amounts of latency, depending on the routing and on how much DSP is in use. Assigning a signal to two parallel paths with significantly different processing on each path can result in extreme comb filtering when recombined. Some digital mixers incorporate internal methods of latency correction so that such problems are avoided. Ease of use. Analog consoles remain popular as they continue to have one knob, fader or button per function, which is a reassuring feature for the user. This takes up more physical space but allows more rapid response to changing performance conditions. Most digital mixers take advantage of the technology to reduce the physical space requirements of their product, entailing compromises in user interface such as a single shared channel adjustment area that is selectable for only one channel at a time. Additionally, most digital mixers have virtual pages or layers which change the fader banks into separate controls for additional inputs or for adjusting equalization or O-send levels. This layering can be confusing for operators. Analog consoles make for simpler understanding of hardware routing. Many digital mixers allow internal reassignment of input so that convenient groupings of inputs appear near each other at the fader bank, a feature that can be disorienting for persons having to make a hardware patch change. On the other hand, many digital mixers allow for extremely easy building of a mix from saved data. USB flash drives and other storage methods are employed to bring past performance data to a new venue in highly portable manner. At the new venue, the traveling mix technician simply plugs the collected data into the venue's digital mixer and quickly makes small adjustments to the local input and output patch layout, allowing for full show readiness in very short order. Some digital mixers allow offline editing of the mix, a feature that lets the traveling technician use a laptop to make anticipated changes to the show while en route, further shortening the time it takes for the sound system to be ready for the artist. Sound quality. Both digital and analog mixers rely on analog microphone preamplifiers, a high-gain circuit that increases the low signal level from a microphone to a level that is better matched to the console's internal operating level. In this respect, both formats are on par with each other. In a digital mixer, the microphone preamplifier is followed by an ADC which quantizes the audio stream. Ideally, this process is carefully engineered to deal gracefully with overloading and clipping while delivering an accurate digital stream over the linear dynamic range. Further processing and mixing of digital streams within a mixer need to avoid clipping and truncation if maximum audio quality is desired. Analog mixers too must deal gracefully with overloading and clipping at the microphone preamplifier and as well as avoiding overloading of mix buses. Background hiss in an analog mixer is always present, though good gain stage management minimizes its audibility. Idle subgroups left up in a mix will add their background hiss to the main outputs. Many digital mixers avoid this problem by low-level gating. Digital circuitry is more resistant to outside interference from radio transmitters such as walkie-talkies and cell phones. Many electronic design elements combine to affect perceived sound quality, making the global analog mixer versus digital mixer question difficult to answer. Controlled ABX double-blind listening tests have not been published at this date. No conclusive answer can be reached. Experienced live sound professionals agree that microphones and loudspeakers are a much greater source of coloration of sound than the choice of mixer. The mix style of the person mixing is also more important than the make and model of audio console. Analog and digital mixers both have been associated with extremely high-quality concert performances and studio recordings. Remote control, analog mixing in live sound has had the option since the 1990s of using wired remote controls for certain digital processes such as monitor wedge equalization and parameter changes in outboard reverb devices. That concept has expanded until wired and wireless remote controls are being seen in relation to entire digital mixing platforms. It's possible to set up a sound system and mix via wireless laptop, touchscreen or tablet, especially if the performance requires no unpredictable fast responses to multiple changing conditions on stage. Computer networks can connect digital system elements for expanded monitoring and control, allowing the system technician to make adjustments to distant devices during the performance. The use of remote control technology can be utilized to reduce seat kills, allowing more paying customers into the performance space. Software mixers, for recorded sound, the mixing process can be performed on screen, using computer software and associated input, output and recording hardware. The traditional large control surface of the mixing console is not utilized, saving space at the engineer's mix position. In a software studio, there is either no physical mixer fader bank at all or there is a compact group of motorized faders designed to fit into a small space and connected to the computer via USB or FireWire. Many project studios use such a space-efficient solution, as the mixing room at other times can serve as business office, media archival, etc. Software mixing is heavily integrated as part of a digital audio workstation. Applications, public address systems use a mixing console to set microphones to an appropriate level, and can add in recorded sounds into the mix. A major requirement is to minimize audio feedback. Most bands use a mixing console to combine musical instruments and vocals. Radio broadcasts use a mixing desk to select audio from different sources, such as CD players, telephones, remote feeds, or pre-recorded advertisements. These consoles, often referred to as airboards, are apt to have many fewer controls than mixers designed for live or studio production mixing, dropping pan balance, EQ, and multi-bus monitoring O-feed knobs in favor of Q and output bus selectors, since, in a radio studio, nearly all sources are either pre-recorded or pre-adjusted. Dub producers engineers such as Lee Scratch Perry were perhaps the first musicians to use a mixing board as a musical instrument. Noise music musicians may create feedback loops within mixers, creating an instrument known as a no-input mixer. The tones generated from a no-input mixer are created by connecting an output of the mixer into an input channel and manipulating the pitch with the mixer's dials. Gallery. Mixing console manufacturers. See also, OSEND, board mix, console automation, DJ mixer, electronic mixer, pan law, notes. References. External links, glossary of mixer terms, mixer how-to.